My name is Fredette. I'm with Red Hat, and I work primarily on the Netvirt project, but some other things as well in Open Daylight. And I'm here with Brady Johnson from Ericsson, who is the project lead of SFC.
Hello.
And we're going to give a short talk on application coexistence. In this talk, we're going to go through the problem statement, what caused the issues, go through some possible solutions that we considered many, but these are kind of some of the top ones, and then describe what we ended up implementing in beryllium and boron, and then finally talk about what's going to be happening moving forward using the Genius project. So the problem is that we had originally were that each application was using the OpenFlow switch without consideration for any other applications. And when we started trying to have some applications work together, we came up with conflicts. And the very first one is what we call the table zero problem. When a packet comes into an OpenFlow switch, every packet goes through table zero, and different projects might use it in different ways. And if two different projects or applications were to write conflicting flows, things can happen. So they'll work correctly independently because we make sure everything is coherent. But then when you put the two together, different things, the right thing probably won't happen. There's also no help really from Open Daylight on resolving those OpenFlow rule conflicts. If they could overlap, you could have a packet might match two different flows, and just depending upon the priority, or if they're the same priority, it's indeterminate which one would get used. The final one is that there was no mechanism for projects or applications to work together to solve a problem. And this really arose as we tried to work out how we were going to have service function chaining work together with some of the network virtualization solutions in an OpenStack environment. And namely, the two that we were working with were GBP, group-based policy, and Netvirt. And this diagram here kind of illustrates those issues. Each of us used table zero to kind of launch into our pipeline, and that's what with an OpenFlow switch, you create multiple tables and with different types of rules, and flow through these tables, and this is referred to as a pipeline. But even once we get up beyond table zero, there could be overlapping use of tables. So in this case, both SFC and GBP were using tables 1 through 3, and then some additional ones as well. They'd process the packet, and when they're done with it, send it out. So this is kind of a brief overview of the problem we're having, and Brady's going to talk about some of the solutions and how we did it.
Yeah. So we had weekly meetings for a while, actually at least a month or maybe 2 months, to discuss
maybe longer.
Yeah. There are all sorts of different solutions we came up with. I even could have been up to 10 solutions, different ways to do it. I wanted to go over a few of the major solutions that we thought about and actually later discarded, then go into the actual solution we came up with. So these are, let's get right into it. So MultiWriter OpenFlow plugin layer. So the idea was to have like a layer on top of the OpenFlow plugin that would handle this conflict resolution. So all the applications could just write their flows the way that they always wanted to, or the way they always have, and this layer would resolve the conflicts. It was a good idea, and we saw that it could work sometimes, but you had to have really complicated logic there. And Yi Yang did this, but it seemed like it was too complicated, and there were too many corner cases. And so we decided to discard this solution. There was another one that we had where you had this per project pipeline. And as you can see, we all share table 0. There had to be some sort of coordination there. But we shared table 0, but only one pipeline is chosen per packet. So depending on the packet, the packet would either be sent to SFC or to GBP or to OBSDB. There was no way with this to, what if I want to process the packet in GBP, then send it to SFC on the same switch? And I think there's one thing we didn't maybe cover in the problem statement of why you would want this application coexistence, and it was mainly for OPNFV. We integrated our projects into OPNFV, OPNFV SFC, which the goal is to integrate Open Daylight with OpenStack. So what was actually happening is we were all writing to the brint bridge on the compute node. We couldn't have multiple bridges. So when that happens, I mean, for SFC, you have either GBP or here it says OBSDB, but it's actually the OBSDB/NetVirt. Either one of those could act as a classifier for SFC. It would classify the packets, would actually map the packets to a particular service chain or another. So, and we had to be able to have the classifier on the same bridge as SFC. So that's why we would want to be able to have the packets either come through either GBP or NetVirt first and then go off to SFC. And this was, as I mentioned, one solution we discussed. Would have worked okay, except that, like I said, we couldn't pass packets back and forth between the applications. And this is kind of similar to what we ended up with, but with some modifications and such. So, stacked pipelines was another one we came up with. We thought, well, we could just stack the pipelines, put them in the order that we think would work, and the packets would just go through all of the tables. And if a particular table or application was interested, it would process the packet and then send it on, or even output it or whatever. But as you can imagine, the ordering of the tables or the pipelines is important as well. So discarded this one as well. So please, if I'm going too fast or whatever, please interrupt me at any time and ask questions, jump in and let me know. Okay. So yeah, as I said, these are three of the kind of the main solutions we considered thoroughly and discarded. And then finally we came up with this solution here. And this we implemented back in beryllium and also use it in boron now. So the idea is that each pipeline has its flows like always, right? But you can configurably offset the pipelines, right? So as I mentioned here, configurable application table offset. So if NetVirt, for instance, uses tables 0 to 110, you can just say your offset is 20. So then it would be tables 20 to 130 or something like that. So you're just sliding your pipelines down, up and down the available tables. And obviously, since there's 256 tables, you could run into problems if you if you slide it too far or try to put too many in there. So we can slide them wherever we want, have this index. Then for the applications to be able to talk to each other, we added the second point here where you can have a configurable egress table, as I called it. I think I coined that one. So what that means is the packets can come into NetVirt, and then when NetVirt, for instance, when it hits the classification part of NetVirt, it says, okay, it's classified, encapsulate NSH, now I want to give it to SFC. So it uses the egress table, as you can see in the box there. We have a pointer, but it's not working on the laser, doesn't work on the screen, but you can see the egress table there. So NetVirt would egress the packets to SFC. SFC would do what they need to do. And then there are certain times, typically what would happen is when SFC gets the packet, then it would send it to the service function. But then there are times when SFC gets it, the packet processes the packets, and then egresses them out to the NetVirt pipeline in the case of with the egress classifier. So we get a little bit of the best of both worlds of some of the previous solutions there. Kind of like stacked pipelines, but we can send the packets back and forth. And as I mentioned in the last point, there obviously we need to share table 0. That works, but we have to have this coordination between us, between the projects beforehand. And it's not hard coded, but it's kind of like I need to make sure I only write these in table 0 and you get these.
Yeah, we had to basically agree, you know, in person or, you know, on how we were going to write these flows so that they could correctly classify the packets to go to the right pipeline.
So
pretty static.
Yeah, exactly, and it works. But I mean, there's always still the possibility of conflict if you don't coordinate back and forth carefully. So, and this is the actual solution. If you look at the OPNFV SFC project that we have working now, this is the solution. This is how it works. Tim Rose from Red Hat had this working in what's called the Brahmaputra release, the previous release. I can't remember when that was, earlier this year or something. And then we have it working also in the Colorado release. So if you're interested in looking at that project and you see the pipelines and stuff, these slides hopefully will help you make sense out of those pipelines, what you see in the tables there. So how are we doing on time? Yeah. So any questions so far? It's a lively crowd. No? Anybody? Is that a question?
So it's static, I guess, right? It's only between NetVirt and SFC. It's not compatible with other applications.
Well, it is. This is the solution we ended up using in OPNFV, as I mentioned. So he's asking if it's static and if there's no other applications. We also could do this with group-based policy. We just didn't get a chance to do that testing. We're about to start the OPNFV release, the D release, the Danube, and that's one of my goals I want to try to do in Danube is to be able to have either NetVirt or group-based policy. And it's the same concept. And I mean, it would work, it would fit nicely, I think. It's just each application has to have its offset, as I said. So group-based policy, there's still 90 tables left where group-based policy could fit in there. So yes, it is somewhat static in table 0, but the individual application pipelines they're not static. I mean, they're just like they always are. Yeah. Other questions?
Yeah. Does an individual application know the offset, or is that all hidden from underneath it?
Yes, it does. I mean, that's part of the RESTconf configuration that you have to set up for each of the applications. So obviously we had to add, for the first 2 bullets there, we had to add these RESTconf messages or the Yang for that. So yeah, we know, I mean, we have to know, right? So normally I'm SFC is writing to table 0 to whatever, 10. I have to know the offset. So yeah, they know that. And obviously, I guess NetVirt, to know where to send the packets to SFC, they're reading that configuration data from MD-SAL. And we receive that, store it in MD-SAL, and then each application can know about that. Yeah.
Yeah. So when you, enable the SFC in NetVirt, it goes ahead and makes these calls to do the offsets SFC pipeline, and then gets that table, the coordinate, the communication channel, basically via the call.
Okay. Does that answer your question?
Yes.
Okay. Yeah. So it's a little bit unfortunate. I wish we could have switched the order of our presentation with the folks from Genius. There's another Open Daylight project called Genius. It's GNS, Generic Network Services, and they came up with a cool name, Genius. So starting in boron and continuing on in carbon, the folks from Genius have another way to do application coexistence, which I think is actually a lot more flexible. It solves the problem here that we have in table 0 where it's static and you have the possibility of the conflict. So I say I wish we could have switched the order of the presentation so I didn't have to go into too much detail today, and you could go to their presentation and they would go into a lot of detail. I mentioned theirs is at Tuesday, 10:40, which yeah, I realized this just not long ago. But anyway, the idea is that they have is basically Genius. They have this module called the Interface Manager. They control table 0. Everyone has to play well. That's the only drawback, but it's not a big deal. No one else can write to table 0. Genius will control table 0. Then the applications register with Genius and say, I want to receive packets from a particular logical port. And when you do that registration, you also send a list of instructions. In the context of OpenFlow programming, you send a list of instructions saying, okay, when a packet comes in on that logical port, execute these instructions, which typically would be a go-to table, right? Go to my set of tables. And Genius will tell you, okay, you can write to this table offset. So again, sliding the tables out. Then when, like as I said before, when there's that particular match from a particular logical port, the interface manager will dispatch packets to the registered applications. The cool thing about it is you can have multiple applications registered to the same logical port, and then you can have an ordering of the applications, right? So yeah. You can have, when a packet comes in on this particular logical port, first send it to application A does what it does, then can send the packet back to Genius, and then it will send it to the next application, et cetera, et cetera. So as I said, this solution is what we have working now. It works quite well. I think it works really well with this limited limited applications. We have SFC, GBP, Netvirt. But with Genius, going forward with Genius, you get a lot more flexibility and remove some of these limitations we had.
And we did that pretty intentionally, that we said, really we need to get these 3 applications so they could coexist. We looked at lots of complex solutions and we said, some of them sound good, but let's just go ahead and let's just get it working. We'll just do it manually, get them to work together, we'll get some experience, and then figure out how to do it more programmatically. And it just kind of coincidentally, Genius was being developed in the VPN service project, and they were also looking to solve the same problem with different, multiple services just within the project. And we looked at it and talked about it at the last design forum, and it looked like, that's something that we can use. And so that's when we decided to break that project out into a separate project that could be used by multiple different applications, and adapt it. And it looks like it's working now with Netvirt.
Yeah.
Now
it's my turn. Now it's SFC's turn to get into that. Yeah. So we'll do that in SFC. We're supposed to talk about that later today, I guess, how to do that. But we'll the 2 projects, Netvirt and SFC, we'll discuss how exactly the timing and all that in the developer design forum today. So if you're interested to know more details about how we're going to do that, come to the DDF and you can participate.
I'll just add that another thing that Genius does is it helps allocate tables. So if an application needs certain 5 tables, it'll tell you which ones to use, and then also manages tunnels so that the different applications can share the same VXLAN tunnels, for example, rather than creating their own.
Yeah. It is nice because, for instance, if you look at the SFC flow pipeline, we're using. For NSH, we're using 3 or 4 different tables, and going with Genius, that will effectively reduce us down to 2 tables, right? Because they're doing all the heavy lifting with setting up the tunnels and making sure that comes in on this tunnel, whatever things that SFC is having to do, things that Netvirt we're having to do. Now we have it, code reuse all in the same place. That's always optimal. You want to try to get that, and now SFC, all we have to do is just kind of the next hop table, the transport egress, just to get the NSH stuff, and then we're done. So we're actually going to simplify us a good bit too. So, questions? Anil? Yes.
Are you using the old network, right? Not the VPN service?
We're using, when you say the old NetVirt, do you mean from OVSDB or? Yeah.
So I'll just,
you answer.
so this particular solution that's working, that Brady pointed to, that is using the old NetVirt. And then when we come together on Genius, we'll use a new NetVirt.
Yeah.
I thought we would talk more about details of these things. I thought we were going to show you this stuff, like next is by session here. So yeah, we will see these things in action. So this is the solution which actually we are using as of now, and I can show you in my time.
Yeah. I have the flows on my lap too. Laptop, if you want to see them. I don't know if we want to go in that much detail. They're ugly and nasty, kind of long flows, but yeah. More questions?
Yeah, I have one question. Do you think it would be possible to have, let's say that NetVirt and SFC are integrated with Genius, but then for any reason GBP is finally not integrated, so would it be possible to have a kind of mixed solution where with some configuration where sometimes GBP and SFC are working in this way and NetVirt and SFC are working with Genius? Do you think that would be a possibility?
Yeah, that's a nasty question, Juanma. But yeah, I think we need to be backwards compatible and continue to work with GBP. I think we should. I mean, we've done this integration. It's actually a really cool use case, the GBP SFC integration. So I don't want to break that. So yeah, we should keep that. So and then there's talk. I don't know if you knew about this. There's talk to see. There's a little bit of duplication between GBP and NetVirt to see how we can somehow put all that in one place and get rid of that duplication. That would be cool to do that.
I've heard something about that talk.
Okay, good, yeah. So then once that happens, I think it'd be a lot easier to use Genius. We wouldn't have to maintain two ways of doing application coexistence. But yeah, I think in Colorado we're going to have two ways to do it. If we're going with GBP, then we'll have to go this way. If we're going with NetVirt or anything else, then we'll go with Genius. Yeah, it's not optimal, but I mean it's backwards compatible. Yeah. Yeah. Other questions? You guys want to see the actual flows? No? Good. Okay. All right. Well, thank you very much. Thank you, Andre.
You're welcome.
I roped you into this. Thanks
Yeah,
for helping.
no problem.
Yeah. Good. All right. Good.